Okay, this is going to be the CDB number 2, so the benchmark number 2 review. In order to do this, you're going to need a calculator, you're going to need your periodic table, and just follow along. Question number 1. Says, according to the law of conservation of mass, how much zinc was present in the zinc carbonate? So you'll get a diagram similar to this. This has been on the exam in the past. And according to the law of conservation of mass, which means whatever is on one side has to equal what's on this side. So what it's saying is that the reactants, and you can go ahead and write this down, must equal the products. Okay, they can do it in a diagram like this, or they can also ask you just to balance an equation, and when we balance an equation, that's with coefficients. However, in this diagram, they gave you a picture. It still means the same thing. It tells us it's the conservation of mass, so it's their weight. This is 64, and this is 192. I'm going to add this side together in my calculator, 64 plus 192. So the reactants weigh 256 grams. My products have to weigh 256 grams. Right now this is 152 grams plus question mark. Well, I'm just going to take 256 and subtract that minus 152. So this weighs 104. So the question says how much zinc was present in the zinc carbonate shown in the diagram. I would say 104 grams. So the law of conservation of mass, however much mass is on the reactants has to be equal to the same on the product side. Take a look at this one. I'm just going to read number 2 before I move it. When 127 grams of copper, when you guys are taking exams, sometimes it helps to highlight or underline, and you can always ask me for a highlighter or a marker. When 127 grams of copper reacts with 32 grams of oxygen to form this, no copper or oxygen is left over. How much copper 2 oxide is produced? Okay, so let's break this up. These need to equal each other. Okay, it took me a little bit to even know what they're asking for. But then they gave me some numbers. So it said 127 grams of copper reacted with 32 grams of oxygen. And they want to know how much did they produce. What do you guys think we have to do? Okay, we're going to have to add these together to see how much all of this weighs together. So 127 plus 32. So the reactants mass is 159 grams. How much do the products have to weigh? The same exact thing. It would have to weigh 159 grams. The products need to weigh the same. So how much copper oxide was produced? 159 grams. So that is law of conservation of mass. Just a reminder that however much one side weighs, the other side has to weigh. Any questions on the front page? Do you guys need the front page longer? Number 3, the chemical equation above shows this is being heated, CaCO3. Which of these statements best describes the mass of the products if 100 grams of CaCO3 is heated? So 100 grams of this was heated. Which of these statements, okay, I think number 3 had statements, they probably pulled it from an exam and there's supposed to be multiple choice options. So we're just going to guess and just answer this to what we think it could be. So which of these statements best describes the mass of the products? So we're describing this. What do we think the mass is? They have to equal the same, okay? This is the third question of doing the same exact thing. So hopefully you guys understand that they have to weigh the same on both sides. So I would say the products equal 100 grams. These are your reactants, and these are your products. The products are what you're left with when the chemical equation is done. So it's coefficient of mass. Anything that says grams is mass. Okay, so if we look at number 4, what's the coefficient for H2O? So we need to just balance this equation. So however many atoms or elements on one side has to be on the other. I'll let you get that down before I explain. I'm putting these little lines here so there's room to write a coefficient. A coefficient is the big number. If you're not sure where I got these letters, there's 1K because there's 1K right there. There's 2 H's because this one has a little subscript, so it says there's 2 H's. There's just 1 O, there's nothing connected to the O. When I come over here, 1K, 1 O, 1 H right here, but then 2 H's right there. So 2 plus 1 gave me 3 H's. This is not balanced though, so I need, this has more H's. I have 2 here. I'm going to start putting a 3, well, wait, a 2. So that gave me 4 H's because this 2 times that 2. This also gave me 2 oxygens. So if I go over here, I could put a 2 right here. That gave me 2 K's, 2 O's, 2 H's. I have 2 H's here and 2 H's here. I don't necessarily add 2 more H's. I just need there to be 2 H's on this side, 2 H's from here, so that's 4 H's. I got 2 H's there, plus these 2 here, gave me 4 H's, 2 plus 2. There's 2 K's here, so I'm going to put a 2 here, and now I have 2 K's here. Are we balanced yet? 2 K's, 2 K's, 4 H's, 4 H's, 2 O's, 2 O's. So the coefficient for H2O is what? Yep, the coefficient is 2. I'm going to scoot that up. I'm going to start on number 5. What are the correct coefficients? What they're asking you to do is balance the equation. So you guys can be balancing it and then you can check with mine. Durant. Good morning. Good. Yes, she is. Yes. Perfect. Okay, I put 1, 5, and 2 right there because that's the ratio of this equation. I just want to throw that in there too so you guys know how to read the ratios. Just because that coefficient's 1, this is 5, this is 2. So 1, 5, and 2. If we look up at this one, what would the ratio be? 2, 2, 2, 1. Okay, so those are ratios. Whatever the coefficients are, you just read them in order from left to right, like you're reading a book. 2, 2, 2, 1. This one was 1, 5, 2. We're going to come back and finish number 6.